Okay, so here's an example. We started an introduction and we were talking about polar rectangles. Here's an example of how the polar coordinates can actually help us in solving double integrals. The problem here is they want us to find the volume trapped between the surface 4 minus x squared minus y squared and above the unit circle, x squared plus y squared equals 1 and everything within it. So this is the region right here. It's going to be our region of integration. So we know from our work in 14.1 right, we know that this represents net volume. And so in this context would be the following. Okay. Again, notice we can rewrite the integrand like this. Okay. Now remember, there are a few equations that relate the rectangular coordinates to the polar coordinates. If you recall from your work, again with polar coordinates, we know that this right here can be replaced with this. We also know from the introduction that dA can be replaced with the expression r times dr d theta. Okay, so how does that change the whole integral then? So here's what we get. This whole integral becomes the following. Now notice that if you integrate with respect to r first, again, this is just going to be a chain rule, and you're off by a factor of -2, okay? So comes down now, once we get this, now it's going to come down to the region of integration, which is this green circle down here, okay? So let's put that right here. Notice in this expression, gang, the value for r would range from the origin out to the disk itself, or out to the circle itself. So we would say then, r ranges from 0 to r equals 1. Okay. Think of it, remember how we were using the arrows for dy dx and dx dy? Okay, think about it like this, here. In polar coordinates, think of an arrow that always emanates from the origin outwards. Okay? That arrow is always going to begin at the origin, and it's always going to leave the region on the circle. Okay? It leaves the region on that boundary. Think of that arrow. How far can that arrow go? It can sweep out the entire green disk if it goes 360 degrees. And so over here we would say then, take theta to range from 0 to 2 pi, okay? Once you get to that step, it's going to be routine calculation, okay? Again, this is a chain rule. You're off by a -2. The hard part was the setup. The easy part is going to be the calculation. Okay, take a few minutes, calculate this value, see what you get.